Well, hello everyone, and welcome to our second video for this e-learning. Now we're going to be continuing our lesson on mixtures, and in this lesson we're going to talk about what types of mixtures are there. In your textbook you'll find that on these pages. So let's quickly recap what a mixture is. So what is a mixture? Well, look at this lovely Coca-Cola can here. And if you look at any drink, soft drinks like Coca-Cola, look at the ingredients. You'll see many different substances inside it. So for example, Coke has caffeine, did you know that? And coloring, some caramel, carbonated water, sugar, and of course phosphoric acid, which is what gives it the acidic feel. So Coke is in fact a mixture that's made out of many different substances. So a mixture, we recall, is made up of two or more different substances that are mixed, but they are not chemically combined, right? They're not like compounds. They're not chemically combined. Now we can classify mixtures and the types of mixtures in a few ways. The first way is to say whether or not the mixture contains elements or compounds or both. So for this, we've already seen it in the last video at the end. Firstly, we have mixtures of elements, which can represent in this way. So here we see the red color balls represent one element, and the green color balls represent a second element, and they're mixed together, but they're not combined. So for example, we could have copper, an element, mixed together with tin, another element, to form a mixture called bronze. We can also have mixtures of compounds, and we can represent the mixture of compounds like this. Like we saw that in the last video. So this blue-red balls combined, this is one compound, and this green-red, this is a second compound. An example of a mixture of compounds is water, which is a compound, H2O, and table salt, which you might know it as sodium chloride, NaCl. This is a compound, this is a compound. We can mix it together to form a mixture, salt water. Now finally, we can have mixtures of elements and compounds. An example of this, as we'll see later, is air. Now air contains elements such as oxygen gas, but it also contains compounds like water vapor, right, H2O, and also, as we shall see, carbon dioxide, or you might know that as CO2. So air is a mixture of both elements and compounds. Now the second way to classify mixtures is by the states of their substances. That means whether it's solid, liquid, or gas. So under this kind of classification, we have gaseous mixtures that are just made out of gases, like air. We have solid mixtures, where two solids are mixed together. We have solid-liquid mixtures, where a solid is mixed together with a liquid. And we have liquid-liquid mixtures, right? So just all the different combinations. So let's start by looking at an example of a gaseous mixture. Now I've got some fresh Icelandic mountain air from Iceland, freshly. And this air is a gaseous mixture. Now if you look at air and you look at the components of air, you'll find that inside air there is different components. There's nitrogen, there's oxygen, carbon dioxide, water vapor, other gases like Ar, which stands for something, go look at your periodic table, and Ne, which also stands for something else. So air is a gaseous mixture made of different gases. Now what type of mixture is air? Is it an mixture of elements, compounds, or elements and compounds? Well, you'd be right to say that it's a mixture of elements and compounds. Right? We've got elements like oxygen and nitrogen, but we've got compounds like carbon dioxide and water vapor. And then we have solid-solid mixtures. Now that's when you take a solid like copper metal and mix it together with another solid like zinc metal, and you get a mixture of these two metals, which may sound familiar to you. It's called brass. Now brass is of course the metal mixture that's used to make instruments, which might be familiar to those of you on like concert band. And this mixture of metals, a mixture of any two metals together, has a special name. It's called an alloy. Alloys are solid mixtures of two metals. It sounds a bit like aloysius. Now, if you look at this in the sort of the diagram form, right, copper we know is made out of many copper atoms, zinc made out of many zinc atoms, and when you put it together, this is what an alloy looks like. Kind of looks like the two atoms mixed together. Now, another example of an alloy is when you take copper metal and mix it together with tin. Now, in this case, the alloy that you get is called bronze. Now, bronze is a mixture of two metals as well. Now, there are other alloys as well, and if you're interested, you can go and find out more. Steel is an alloy. Stainless steel is also an alloy. So go look up at what it's actually made up of. Now, on to liquid mixtures, and for this, we go to the kitchen. We find a bottle of vinegar. Now, vinegar is actually a mixture of water and ethanoic acid, CH3COOH. C is what it's made out of, right? There's C, carbon, hydrogen, carbon, oxygen. Right, so water and ethanoic acid mixed together gives us vinegar. If you're sharp, you realize that this is a mixture of two compounds, right? Water is a compound, and so is ethanoic acid. And finally, we have a solid liquid mixture. Now for this, it's a very simple example. It's just like taking salt mixed with water. So we take the salt and we dissolve it into water. That actually makes a solid liquid mixture. Now what type of mixture is salt water? It is a mixture between two compounds, right? Because water is a compound and table salt is also a compound. Now, as a quick point of interest, notice that this mixture is clear, right? It's colorless and it's clear. So not all mixtures are kind of muddy looking or cloudy looking. There are some mixtures which, when you mix a solid and a liquid, it's actually quite clear. And this we'll look at the next lesson. Next time we come back to school, it's called a solution, right? Where salt is dissolved into water. Now, for the last part of this lesson, we'll be looking at what are the differences between compounds and mixtures, right? So compounds versus mixtures. Now let's think of a compound, right? For example, we've been talking about water, and water is a compound, and water we know has the symbol H2O. That tells us that there's the element hydrogen and the element oxygen inside water. Now, a mixture, for example, would be a mixture of, let's say a mixture of hydrogen gas, which you can find in the air around us, and oxygen gas. Now, in this case, the mixture also contains the element hydrogen and the element oxygen. So what makes the compound water different from a mixture of hydrogen and oxygen gas? We're going to be looking at that question. How do you differentiate a compound from a mixture? Now, the first difference comes from comparing the properties of compounds and mixtures to the properties of what they are made up of. Now, the properties of compounds are usually different from the elements that it is made up of, while the properties of mixtures are usually similar to the components that it is made up of. Now let's use some examples to make that clearer. So for compounds, let's think about table salt or sodium chloride. Now the properties of this compound, table salt, is that it's kind of crystal-like and white in color. It can be eaten. Now that's very different from the properties of the elements that it is made up of. For starters, Sodium is actually a metal that reacts very explosively with water. And chlorine is actually a gas at room temperature that's poisonous. So take a metal and a poisonous gas, put it together, and you get something that's edible. So you can see that the properties of a compound are very different from the properties of the elements that make it up. Now, on the other hand, the properties of a mixture are usually very similar to the components it is made up of. So for example, air is a mixture that contains oxygen. And oxygen is involved in, explosive burning reactions. And because air contains oxygen, it too can be involved in explosive burning reactions. So the properties are actually quite similar. The mixture, in a sense, takes on some of the properties of its components. Now, secondly, for compounds, the elements which make up the compound are always combined in a fixed proportion or ratio. However, in mixtures, the components which make up the mixtures do not need to be mixed in any fixed proportion or ratio. So take, for example, water. Water we know has the symbol H2O. Now that tells us that for every 1 unit of oxygen that we find in this bottle of water, we will find 2 units of hydrogen. That means it must always be 1 oxygen combining with 2 hydrogen. That's the ratio that is fixed. You will never find another ratio. Now in a mixture, however, the components do not need to be mixed in any fixed proportion. So for example, if I'm making a Milo drink, right, it's like putting Milo powder plus water to give me that drink, right? Now, does it matter how much powder I mix with the water to give me a drink? Not really, right? I can put a lot of powder into the water or not so much powder into water and I'll still get the mixture, which is the drink. So a mixture can be created by mixing any amount of the 2 components together. You don't need to mix them together in any certain ratio. But you can only create a compound if you combine the elements in a certain ratio. So it'll always be 1 unit of oxygen combining with 2 units of hydrogen to give me water, nothing else. Now finally, compounds cannot be broken down into the elements which make it up by physical methods. They can only be broken down by chemical methods, right? For example, we saw in your earlier lessons that it can be broken down by running a very strong electrical current through it, right? In a process called electrolysis, right? So actually water can be broken down into its elements. Now mixtures, the components of a mixture can be separated by physical methods such as evaporation. Now if I took seawater, which is basically salt water, and I evaporated it, right? I heat it up until a very high temperature and all the water evaporates off, then I would have separated the salt from the water, which is what's happening here, where the salt actually gets separated from the seawater because of evaporation. I can't use evaporation to, separate hydrogen and oxygen from each other in water. If I heated up water with evaporation, you just get all the water evaporating. I don't separate my hydrogen from the oxygen. So that's basically it. And I just like to end off by thinking again about that question. How is water, which is a compound, different from that mixture of hydrogen gas and oxygen gas? Well, the first thing to say is water has very different properties from hydrogen and oxygen, right? Both of these are gases at room temperature, but water is a liquid. Whereas if you have a mixture of hydrogen gas and oxygen gas, the properties of that, which is a gas, is still similar to its components. Each component is still a gas. So that's one way of looking at it. Alright, try the quiz and see if you've learned something.